Hey everyone, welcome to another visual effect tutorial. In this video, we are going to create this amazing Tesla gun. I've created this lightning movement with simple shader code. This lightning is going to be fully interactable with other objects as well. So let's create this. Now before jumping in Godot, let's talk about some images that you will need. If you are watching my channel, then you may already have this image pack. For the new viewer, go to this website and there you will find this image pack, which is made by Kenny. It contains amazing images, so just download it. Now we have everything. So let's open Godot and there we will create a new scene of raycast 2D. Then under it, we are going to add a line 2D node. Now select the raycast and in the inspector, first enable it. Then cast to is the direction where our ray will point. Set it to 100 on X and 0 on Y. So our ray is pointing in the X-axis. Now collision marks tell us from what object our ray can collide. So you have to set it according to your game. In my game, I want it to detect the player and to the world. So I will set it to true in the player and the world layer. Now depending on your game, you might want to detect the areas as well. So turn this on if you want. Now coming to our line 2D, we first click on this add point icon and then create 2 points. Now in the inspector, click on this pool vector and you will see the coordinate of these points. Here set the first point to 0, 0 and in the second point just make sure that Y is 0. X can be whatever you want because we will change it from the code. Now in the width, set it to 150. Then coming inside the fill, here you will set the texture of the line. For that, go to the image pack you downloaded and in the rotated folder, you will find the Spark 06 image. Now add it to the Godot and then put it inside the texture slot of the line 2D. Now in the texture mode, set it to tile. Now you need to enable the repeat on the texture. For this, select the image and go in the import tab. And then enable the repeat and also click on re-import. Also in the inspector, click on default color and make it white. Now this time to add some motion in it. For this, we are just going to write 2 lines of shader code. So come under the material and add new shader material. Then in the shaders, add new shader and then click on it. Here we are going to write shader code. Now if you know a little bit about shader, then that's great. But if you know nothing about it, then I have made a grass motion video some time ago. I recommend it watch you first because there I have explained the shaders basic. And the code I used to create the grass motion and the code I used to create this splash effect is almost the same. So if you have watched that video, then it will be helpful. So coming back to the lightning, here we will first write the shader type canvas item. And here we are only going to need the fragment function. As you know, the fragment function have this color value that tells GPU what to draw. Here we are going to give this texture function and pass our texture and UV. This texture represent our image and along with that we are passing UV in the texture function. This texture function take an image and a UV coordinate and then return the value to the color to display the image on the screen. Now to move it, we are going to make changes in UV coordinate. So for that, I am going to create a UV variable and set it to our uv.x and uv.y. And instead of real UV, we will pass our own UV. Right now nothing changes because we haven't changed anything. Now to move it along the x-axis, we will add time variable in uv.x. So now our lightning start moving in the x-axis. You can change addition to subtraction to change its direction. If you like this, then you can leave it like that, but I am going to make it move left and right. So I will add this inside the sine function. Now to change its wavelength, I will multiply it by a smaller number like 0.1. And to increase its frequency, I will multiply time by a larger number like 80.0. Now we are going to do the same thing in the uv.y. Now just to make it little different on the x and y axis, I will multiply time with 50 and multiply whole thing by 0.02. And congratulations, we are done with our main lightning. Now it's time to add some spark at the end of the lightning. Don't worry about the color right now, we are going to set it at the last. For spark, we will again head over to the image pack and take this spark 01 image from it. Now in our laser scene, we will add a node 2D and we will name it end. Under it, we will add a sprite node. Now in the sprite, add our spark image in the texture slot. Since the image is too large, so scale it down to 0.1. Then under the material, add new shader material and open the shader editor. Now write down the shader type and create the vertex function. Now if you have watched my grass motion video, then you will know that there we have moved the top part and keep the bottom same. Similarly, here we are going to move the left part and keeping the right same. Now write vertex.y because the movement is on y-axis. Then we pass time in the sine function and to increase its range, multiply it by 200.0 and to increase its frequency, multiply time by 80.0. Then multiply it by uv.x this time because it changes from 0 to 1 on x-axis. And to invert it, we subtract it by -1. So now it's going from 1 to 0 on x-axis. Now our spark is also completed. Now just duplicate our spark and under offset, flip it vertically. Now just make sure that the position of both sprite is set to 0, 0. Now go to our end node and make sure that its y coordinate is set to 0. You can change x whatever you want because we are going to change it from the script anyway. So now let's attach a script to our raycast node. Here first we create a variable that contains reference to our line 2D and a variable that contain end node and a variable that represent our maximum distance that our light can go. Then create a ready function and here cast the ray to our maximum distance. In this case maximum distance is 1000. That means our ray 2D is 1000 pixel long. Now create physics process function and inside it we first check it for collision, and if our ray collide with something then we will store that position in a variable. Since this function return global coordinate but we want our local coordinate, so we will use toLocal function to convert it. Now when we get the collision point, then we set the second point of the line 2D to that point. This will increase or decrease the line based on the collision point that we get. Now also put our end node to that collision point. Now since everything is placed on x-axis, so whatever collision we will detect will be also on x-axis. So in the code we can only set the x coordinate because y is always going to be 0. Now only one problem's left. You see currently our line is set to 200 pixel and if I put the end node at 200 pixel, it will go to the end. But because of this sprite, it look outside of the line. So we have to bring it back a little. For this, you need to shift it 15 pixel on left. So in the code, we will subtract 15 from it. Now we are done with the coding and it's time to add some color to it. Now click on line 2D and come under visibility and select modulate. Then switch to raw mode and set 12 to 3 in the red, blue and green. Do the same thing with the end node as well. You don't have to just copy this value, feel free to try different values. Okay, our lightning is fully ready now. Just create a gun image that will fire it and add the lightning scene in it. Then place it where you want. And that's it. I hope you found this video helpful. If you have any doubt or any suggestion, write down in the comment section and also like and subscribe to this channel and I'll see you guys in the next one.